Hi and welcome. Today we're going to go through how to do a measurement on a medium voltage circuit breaker with the help of a TM. Here I have a TM1800 and I also need a power supply or a DC supply in a station. I'm going to use my B10E for this measurement. For the measurement you need the standard cables for B10E and TM1800. But since I'm going to do a dual ground simulation here, I also need to have cables to short circuit the breaker to simulate the ground. You can use long, normal banana cables or the auxiliary cable for TM1800. Auxiliary timing, because there you have even 4 cables. You need 3 cables. Another thing you need is to charge the motor of a breaker. Then you need a power supply cable there, and you need an extra loop to connect a minus. Let's start with the connection works. We start with the grounding. We connect the grounding in the structure of a circuit breaker and ground in the B10E. Another ground to the instrument. Now I'm going to do the preparations to simulate dual ground. First cable on phase 1 to the other side. Phase 1. Phase 2 to the other side of phase 2. And phase 3 and to the other side of phase 3. When you do these kind of connections with real grounds, make sure you have separate grounds at least on one side. We continue with the supplies. We will need supply for the motor. Plus and minus. To motor supply on the B10E. I continue with the supply for the coils. I need to link the minus and the plus between the channel used for close and the channel used for open, which is these 2 channels on the control module. Now I need to use the control cable. I connect plus and minus to the same channels. And plus and minus to B10E. I need to link here, make sure this one is linked. I continue with the operation cables, the close and the open. The yellow for close and the green for open at the circuit breaker. I continue with the dual ground cables. Phase 1. I need to use the clamps. Phase 1. One side. And the other side. What's important here is that this loop, this opening, needs to be separated. They can't be in this position when you do dual ground. So put them a little bit separate. Continue with phase B. Again, make sure they are separated. And there is another thing to consider here. This can't intersect with the other phases. So you need to not only make a loop, but also a loop that doesn't intersect with the closest channel or the other channel. If you do this on an outdoor breaker, this will not be a problem because the distances are naturally so long. Continue with the last phase, phase C. And again, make sure you have a loop and that it doesn't intersect with phase A and B. I also need to connect the DCM to the timing MR because these two channels are working together during this kind of measurement. The D sub cable to the DCM, dual ground module. Phase A, B, and C. So for doing only a timing, you are not prepared with the measurement connections. But I also want to do an analog measurement. So I'm going to do a motion measurement with the analog channel. So I connect my analog cable from the instrument and to the mounted transducer. I'm not going to go through in this video how to do this because that's a long process. It's very important how to connect this in the correct way. So I have pre-made this connection. You use a transducer cable and the analog cable as an extension. So this is a rotary analog transducer used in this case. Important that the cables also are not interfering with the mechanism here. So make sure they're not in the way, also that the mounting of the transducer is not in the way for the mechanism so it can do its operation. Now I need to connect one more thing, and that's the supply minus to the coils. I need the minus to meet the pulse. And like that, now we only have the supplies to the instrument and to the B10E, the AC supply. For the instrument and for B10E. Before we start with the measurements, we need to prepare the dual ground system for the measurement. We have to make sure the breaker is closed first, so I closed my breaker, and now I need to tune it. I do that by pushing the tune button of a DCM module, and the instrument will immediately start the tuning process. And you see the LEDs flashing, and when they're finalized, the channels used should have a steady light to be prepared. There you go. So now we can start the measurements. Check the voltage supply needed for the breaker. In my case, 110 volt DC. So put it to coil and turn it up to 110 volt DC. Check the motor. You need to charge the motor first, so you need about 110 there as well. And run the charging, which takes about 13 seconds. Go back, so you have coil. Check that you have a link, and then you're prepared to do your operations with the instrument.
I start with defining a new breaker from template. I go to generic templates. One breaker phase my breaker has. I only have one drive, and I don't have resistor contacts. Here I have to decide whether I want to measure motion or not. And I want to measure motion, so I select that one and I give it a name. And back and accept. Here we see the basic configuration, but I want to do some changes. I want to turn on the motion measurement. I'm going to use an analog transducer, but I don't know the details of this breaker, so I'm going to use relative. And since I don't even know the stroke, I use 100 millimeters. The speed points I use for standard settings of the instrument. I create a new test. And as you remember, we closed the breaker, so we need to start with an open operation. We go to hookup and diagram. Check our connections, close here, open here, and you can get connection information here, how to connect your breaker. In this case, we're going to do dual ground, and it looks like it's turned off here, but it's actually using these channels still. And here you can see details, how your transducer should be connected. Now I'm ready to do my operation.
After that, we continue with the open operation. We turn the knob again. And the breaker will operate.
Here I see my open operation. I see the three timings. I see the motion and the coil current. The coil current is very small and the motion is placed over the graph. So I'm going to move it. I'm going to do some changes here. I'm going to make the current bigger. So I need to do the Y scale smaller. And I'm going to move the motion up, and I want the scale. I'll try with 10. Oh, 10 got a bit big. Okay, I go back and change to 50. Coil current, motion, and the three timings. And here on the parameters, I can see my results. And the breaker operated open within 54.8 milliseconds.
I do the close operation. So the breaker is going to operate now.
Here I have my free closing traces. I have my coil current and I have my motion trace. I can see my coil current is very small, so I'm going to change that setting a little bit. Change that to 0.1. And results. It closes in 82.3 milliseconds, so it's a rather slow breaker. I leave to continue for the other operations.
When you do this type of measurements, don't forget to take safety seriously. Follow the local safety instructions, and yeah, thank you for listening.